Great. Okay, so welcome everybody to today's Python tutorial. So this is our first workshop for the day, and today we'll be looking at we'll be focusing on the package Pandas. And so as we always start, once you log into your hub, got it. You just navigate to this folder. So coercing Python 2023. Yeah, yours might look very different from mine. And so that shouldn't bother you too much. So move through the PTR Foundations folder, and then you navigate to Pandas. And then you open your Pandas notebook. I think it would be nice if you can all open your notebooks and follow along, so that if you face any issues, yeah, I could help on the spot. Yes. So like I said, we're focusing on Pandas today. So this is a package that helps us to deal with tabular data. Examples including like CSV files, and you can, or spreadsheets, or database printouts. And sometimes you can even have like text files, but they are tab delimited. And so you can also use Pandas to handle them. So overall, I'll introduce you to the Pandas data structure. We'll go through how to slice and dice Pandas data frames and data series. And then finally, we'll try to use, hopefully we'll have time. We'll try to see how to use Pandas to perform some exploratory data analysis. Yeah. So as you can see in your notebook, there are a couple of content listed that probably you need to have already been exposed to. So I think we covered NumPy on Monday, and I hope that most of us are comfortable using it now. And so as we usually do, like when you start your notebook, the first thing you want to do is to import the libraries that you are going to be working with. And today, as I already mentioned, we're focusing on the Pandas library. And so the popular keyword used to refer to Pandas is PD. And so just like you saw yesterday, I think when Kewe was introducing XArray, when he was importing the XArray package, he imported it as XR. Similar to NumPy, you use NP for that. And so when using or working with Pandas, you use PD, which is the norm within the community. Yeah, so we all have adopted this, and so we all use it. Yeah. And also we'll be working with data, and this data is in the PTR data sets. And so we need to import data sets from the PTR data sets package. Yes, so Project PTR is our resource. That's the main resource we are using for our tutorials. And so that's what you do first. And so I'm just going to run this cell. And so once the cell has been run, you've already loaded the packages. And so this is what this diagram that you see here is what the Pandas data frame looks like. And so you have it's a two-dimensional data, has a two-dimensional data structure. So you have columns and you have rows. And so usually what you find is that when you have your data, the columns contain all the information or observations within the column are all related to one variable. So you're going to have some variable here, and then all the observations in this column will be about this variable. Then you're going to have another variable And so that's how the columns all contain information about the same variable or the same entity. And when you consider the rows contain, so if you have different column headings here, you will have information about this single sample for different variables. So let's say you have temperature here, you have salinity, you have dissolved oxygen. All this, all the observations about these different variables will be for this one sample. And then for the next sample, you have information for different variables related to the same sample. Yes. So hopefully that was not confusing. I should think that most of us usually work with how do you call it? Tabular data. And so, yeah, this should not be too confusing. And so the columns, okay, so I'll just read what they have here. The columns make up the data frame, or the columns that make up the data frame can be either dictionaries, NumPy arrays, Pandas series text, or other data types. And so that's the content that can occupy the columns. Okay. And one more thing to mention, usually have the index which labels the rows. So this first column usually labels it usually refers to the index, and it labels the different, the different rows that you have in the data frame. So to start, we are going to read in some tabular data, and this data is going to be from the PTR data sets, yeah, which we already imported. And so, yeah, so we move to the next cell. And so I'll run this.
Yeah, hello.
Hello?
Yeah. Yes.
You have a question? Hello? Is somebody talking?
I think they're just not on mute, so you can put them on.
Okay, thank you. Okay, so we just ran this cell, and so we've so we have this object, and we've loaded the path for this data into this object file path. So I've already run the cell, but let me print this file path. So this here, when you print this object file path, you see the path for this data set. So it's being stored in a cache. And so probably I'll just keep it there. And so once you have provided a valid file path, you can now use the module read CSV within the Pandas data frame to load the data into an object. So we want to load the data into this object we are calling DF, which is standing for data frame. It's short form for data frame, so DF. And so once we already have our path, I'll run the next cell. And so what happens is that the data has been read into this object, and so it's been stored in the object. So we want to try to see what the data actually looks like. Is it really tabular data? And so I print this, but what you see is that when you use the print function when you print the data frame using print, it renders the output as some kind of text style tabular data. And sometimes this is not too, especially if you have a really large data set, this might not be too it might not be easy to read or to, yeah. So what we do is that we can just call the object directly without subjecting it to the print function. So if we call the object, which is df, you realize that it renders the output like nicely, and we can already see the different column names. We can see the indices or the indices for the rows, and we have some datetime variable. Yes, so just a brief note on this data set. So is data the data contains information about the El Nino Southern Oscillation phenomena, and so that's what that's the phenomena we'll be exploring as we learn. That's the phenomena we'll be using Pandas to explore. Yes, so I don't know, maybe I'll show us what the, I don't know, maybe I'm trying to see if, I think there should be a link to okay, just quickly, I'll go onto the PTR webpage. I think that there should be a link where you can get like information on this El Nino La Nina phenomena. And so so as you can see, hello Alfred, could you kindly mute
They
yourself?
are doing their course selection, so I say Baja should help them.
Is it?
They are come to do their course selection.
Wow, how do I mute this? Yeah, so if you write and okay, so probably it should be in our file also.
This thing, no.
Yes, okay, yes, so hello. Let me try and see if I can mute I don't know. I cannot find him. Okay, we'll just continue and hopefully we won't have any disturbances. So within your notebook, if you click this link, it will open a new web page which provides more information on this El Nino Southern Oscillation phenomena. And so you can use that link to read more about the phenomena. But I just wanted us to, just so we can relate more with the data, just to see where the area where the data is coming from. So it's somewhere in the Equatorial Pacific. Oh, it's still loading. Okay. It's still loading. Maybe we'll just continue, and then if I get my page up, I'll take us back. Yeah. Okay. So where were we? Okay, I guess probably it's finished. Yes. So this is the area where the data that we are working on is coming from, and so you have some indices that have been computed for different areas, and so that's what you see in the data sets that we've opened in a notebook. So this is somewhere in the Equatorial Pacific, and you usually have this phenomena that is related to anomalously warm or cold surface waters building in this area. Yeah, so you can read more about that. Yeah, just to help you better understand the data you're working with. Yes, so I'll continue. So like I said, if you just call out the object name, the object for which you've used to store your data frame, you just call out the object name, it will render the output nicely. And so this is what you see. So we have column names are unique names, and then overall you have 472 rows and then 9 columns. But here you see that the last row index is 471 is because like as we've already learned in Python, you are usually counting or number is usually starting from 0, and so you still have 472 rows, so it's ending at 471. Yes. So what you see is that you have, so like I said before, so if you see any kind of Pandas data frame, or yes, any kind of Pandas data frame, what you have is that you have each variable, you have data related to, all these observations are related to this one variable. And then across the rows, all the observations are related to this one sample, this, or this, in this case, since we've not removed the index, all this information or observations are related to this in first index, which is at 0. Yeah. Oh, okay. So in the next cell, we try to see what the indices is, which you already saw here. So the indices are starting from 0 and ending at 472 with the step of 1. And you know that usually when you have this, the last number, the end or the stop is usually not included. It's exclusive of the stop, and that's why it ends at 471. And so it says what? So currently the data frame is not very helpful for us. Why? Because we can make it better, to make it more human readable, to make it more appealing to our eyes, to make it more easy for us to view the data, I guess. And so Pandas has a few tricks or a few functions that can help you better observe the data, yes. So what you do, we are still using the read CSV function within Pandas. And now, instead of just providing a file path, we are going to provide a value for the index column. So the index column is this one. And so we are going to provide a value for the index column. And then we are going to pass this dates equals true, which tells, so if you use dates equals, if you pass dates equals true, it already tells Pandas that you want to set a date time object as your index. And so it helps it speed how it reads in the data. Yes, this might not be too obvious when we run this. I mean, it was fast enough, but when you work with really large data sets, like it's helpful if you already tell Pandas that, okay, you'll be reading in a datetime object as the index. So once you prompt Pandas, then it will know, it will speed up the reading in process. So that's what we do here. And so you realize that now, once we set the index column as 0 to this, we set the index column as this, and then we pass the dates equals true. This is what we have. And so now our various rows are identified by this datetime object. And so, yeah, and they're all unique values. So we want to print out the index again, just to see if it really has changed. Yes, and indeed it has changed. So you realize that you now have the index as the datetime index, which is it's a list of unique datetime observations, I guess. And so the advantage this gives us is that we are able to uniquely identify the various columns, like as you can see, with unique names. And in that same way, we are also able to uniquely identify the different rows using the unique datetime index. Okay, so next we want to see the various column names that we have. And so just as listed in the table, you have the various listed here. Hello, Alfred.
You have his number.
Huh?
You have his number.
Come for his number.
Daniel, if you want to mute people, you just put your mouse over their name, click on the 3 dots, and there should be an option for you to mute.
Yeah, but because I'm on a full screen, usually I cannot see nothing.
Oh,
Yeah.
if you make me co-host, I can do it.
Okay. Yes, I think I'll do that. Okay, I probably need to find you. So Shanice,
Or actually, I can do it. Hold on.
okay. 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 Okay, thank you. I hope it's done, or it's not.
Yes, it's done.
Okay, thank you. Okay. So where were we? Okay. So we've now looked at the pandas data frame, what the various parts of it. Next up, we will have a look at the Pandas series. So the Pandas series is essentially like one of these columns, one of the columns of the data frame. So every unique column in a data frame is a Pandas series, or can form a Pandas series, yes.
Daniel, you have a question. Someone's raising their hand.
Okay. Okay, please, if you have a question, kindly open your microphone and speak. Yes. I think now.
Okay.
Yes.
Mr. Daniel,
Yes.
please, at the top you said define the integer. Yes, it's run as a datetime integer. Right, where it listed all the list of the datetimes, and at the end it says D type, datetime 64, NS name, datetime, length 472, frequency none. I want to
Yes.
understand the side of the frequency. What does it really do?
Okay, cool. Thank you. Good question. Sorry, I cannot see your name, but I'm not sure.
Benjamin.
Benjamin, okay, yes. Thank you for the question. I'm not sure what the frequency does. I've never investigated it before. Shani, is any ideas, or I'll just look it up quickly.
Sorry, what was the question?
So so on the screen now, so I've tried to print the current index for the data frame.
Yes.
And if you look at the datetime index, you see at the bottom, you see frequency equals none. Benjamin is asking what the frequency means. I've not investigated this, and so I don't know if you have some ideas. If not, I'm just checking.
Frequency usually means like how frequent is your time dimension? Is it monthly? Is it daily? Is it hourly? But I'm not sure why it says none here. Yeah. Yeah, I can't answer that, I don't think.
Okay, but this is daily data, like as you can already see. So Benjamin, what I'll do, so later in the day we'll have what do we even call it? This help desk, okay? I'll look into this, and if you meet me later in the day, yeah, I'll try to get a response. I hope that is acceptable for now. I hope that is okay.
Yes, please.
Okay, thank you.
Thank you very much.
Okay, so continue. I hope you can hear me.
Yes.
Okay. Yes, so yeah, I was talking about the Panda series. And so like I was saying, every column in the data frame can make up a Panda series, or every column in the data frame is a Panda series, yeah. So the various columns, yeah. So it's a one-dimensional array, and it's similar to the NumPy arrays that you saw on Monday. So we'll just try to subset one of the columns and see how the series will be rendered. Okay. Okay. Yes. So what you see is that we've just subsetted one column in the data frame, which column was that? Where are you? Okay, the Nino 3, 4 column, the column with the name Nino 3, 4. Yes. So this column. So this is what is constituting our Pandas series, and yes. So you see that the data or the observations here are the same observations in the data frame under the column Nino 3, 4, and it's always accompanied by the unique index, and so that's how come you still have the daytime indices that we added to the data frame. That's how come you still have it here. Yeah, so this is one way to subset using the square brackets. And then you can also use the dot notation to subset columns. And so I run this quickly. So you still have the same output.
Daniel,
Yes.
please don't forget to plug your laptop. Yeah, you may run out of battery soon.
Thank you.
Yeah, and just a quick question about the way that you print the column out. I wanted to find out if you have a specific way to specify the number of rows you want to display.
Okay, thank you for the question. Yeah.
Yeah.
Yes, so yeah, thank you. I think I should have power now. Yes, you are asking. No, so we'll get there.
I'm asking you, you see now there you are displaying, I think five rows. Yes. So maybe I want to display something around 100 rows. Is there a way to do it so quickly?
Yes. Yes, there's a way to do it, and we'll get there shortly. Okay.
Okay.
Yeah, if you just give it a bit, like a couple of minutes, we'll get it very soon.
Okay, thank you.
Yeah, you're welcome. So yes, if anybody has a question, you can just open your mic and chime in. And yeah. So next up, we want to look at slicing and dicing, Pandas data frame, and then Pandas series. And so yes, we are getting to your question. I don't know whether it was Emmanuel. Sorry if I missed your name. So yeah, we want to slice some data, which is yeah, as the name suggests, yeah, we'll be cutting part of like a whole to just have a small portion. And so we are going to index the Pandas series that we had. No, we are going to index to create a series. And so I'm running it, hopefully, yeah, I've run the cell above. So I'm running this next one. Okay. So we created this series, and then we pass the data to this object Nino 3, 4 series. And so we printed it out, and yeah. So around so as you did in NumPy, you still the same method for indexing, like maybe list or NumPy arrays. It applies here. So we'll just try one. So for the series that we have, if we want to see the fourth, so in a NumPy array, it would render it the values horizontally, but as you see in the series, the values are rendered or the data is rendered vertically. So, and it's the same, like I mentioned, as the NumPy array. So if you want to see the value in the fourth position. Yes. So that's 3 because you're starting from 0. And so what you find is that the output here is 28.02. And so 0, 1, 2, 3. And so, yeah. So we have the same value. So this is with regards to so if, for instance, let me try this. Okay, 101. Let's see. Okay, so this is similar to the question that I don't know who was, but Emmanuel, I guess, who asked the last question. He was asking if you
it's
just
Emmanuel.
wanted. Okay, great. Yeah, you were asking if you wanted to if you just wanted to subset like a portion of the data, like. So this is how to do that. If you just have a series, like this is how to do that. But you apply the same idea if you are working on a data frame. Like we'll get there, but I just wanted to show us quickly how probably we could do something of that sort. Like without these values, module attached, it still renders it like how we had it initially here, only that now the observations we've limited it to the first, I think the first 100. Yeah, the first 100, because or the first, yeah, first 100 or 101, because there is first 101 observations. Yeah. Okay, so what did we have here? Okay, maybe I'll just leave it. And then okay. So I'll just go back to what we had initially. So the other thing that you could also do when you are working with a series, that you could also index the values based on the index labels. This sounds confusing. Indexing index labels. So the labels. So now that is a Pandas series, these are the unique index labels. So you can view a specific data point or value using its corresponding label. And that's what we have here. And so if you run this cell, you're going to have the same value because it's still referring to this this observation. Yeah. And yeah, so like I did before, okay, so we already have an example here.
Please, Daniel.
Yes.
Apparently, it looks like the 1982-0401 is the observation name, right?
The 1982-0401 is the
observation name, because since you've asked
the label, yes.
So initially my question is to display, when you are displaying the the data sets.
Yes.
Okay. Instead of displaying four observation, you want to display 100 out of 10,000 or 1,000 lines you have. So that was my question. As we always do, sorry, I'm R user, I'm new in Python. So in R, we just need to write the data set and write head and comma, and we specify the number of lines we need to display. So I just want to find out if this is applicable here.
Yes, so it's applicable. You can also you can run df.head and you just see the first 5 observations. Then you can also run df.tail.
Okay.
So,
yeah.
Yes. Yeah. Well, I think it should be. It's somewhere in the tutorial, but let me just try and see. I think it should work. Yeah. So this is if you just want to view the first.
Yeah.
Yeah. So the head just gives you the first 5 observations. Yeah. It's it's down in the tutorial somewhere. Yes, because when I went
Okay.
to I saw
Okay.
yes, but you can definitely do that. Yeah,
Okay, thank you.
yeah, you can definitely do that. And where were we? Okay, yes. So, like I mentioned, okay, yes. So you can view specific data points using their corresponding labels, or you can use their index position. Okay, so I already run this. However, I'm going to okay, so these are the two main ways to index the series using either the labels, or if you are using the array method, like you are using numbers to indicate the specific data point you want to view. Okay, so now we want to build on what before this started. And so if you wanted like a range of data points, you can specify a range of labels. And so this is what you have here. And so here you can see for the same series that we've been working on, you can, so now you don't see just one value because now we've subsetted or we've tried to slice a range. And so from this label, this first label up until this last label. And what we need to note here is that, so when you use the label notation, the end label is inclusive, but then when you use the numbering or the index notation, it's exclusive of the end value. Yes. Okay. Okay, there's another function or another module that we can still use to index the data, and that is called slice, which is quite intuitive. And so you can already understand what it means. So we can still slice the series, and this output is still similar to what we have here. Next up, we are going to look at how to use, we are going to be using dot notation, and we're going to look at how to use this ilocate, and so iloc and then lock, I guess, means location. So index location, I guess that's why you have the I. And so this is just location. So when you want to use labels, you use the dot lock. And then if you want to use indices, you use the iloc. Yeah, so we just go through a couple of examples. Yes. So within this series, so basically what we have here is that within the series, index locate kind of like the value in position 3. So it's similar to what we had above. And yeah, same here. I'll just run the cells because the output are not that different from what we had from the beginning. So as I mentioned, you use this iloc for the indices, and then you use the lock for the labels if you want to slice or series, or yeah, eventually if you want to slice a data frame. I think yeah, use the labels, use the lock here. I'll just run this. Okay. So the same output, hopefully I'm not mistaken here. Okay, so now I want to see some interesting stuff. So all this while, we've been applying the indexing on a series, but now I want to see if it's possible to apply it on a data frame. So we use the square brackets, we provide a label, and then we see if, I think it's going to be an error. Okay. So we get an error, which means that it's not possible to slice the data frame directly. And yeah, quick side note. So when you are working in Python, you usually have errors. Usually there'll be a lot of, usually the easiest thing to do is to just copy the last part of your error message. You can copy, put it in Google, and then you try to, I mean, if you're working by yourself and you don't have any help, yes, Google is always a place to go. And you can just copy your error message, paste it in Google, and then you'll definitely find solution. There's a big community out there, with support. So you will definitely find a solution. And always, I find that always the end of the error message is what usually matters, usually says a lot of things here. But usually the end is what you should really be focusing on, because it provides a good idea of what your error is. So I'm just trying to get rid of the error message.
Daniel, could you try maybe double brackets instead of single? I just want to see if that works.
Okay. I don't think it will work. Okay, we'll see.
Yo, I don't know.
I think when you do the double brackets, if you have two columns, if you have two column names, so this if you use column names, you can make it work. So if you use column names, you can make it work, I think. Let me just try.
And iLock doesn't work, or lock?
I think they work.
Oh, you're just showing a different way.
Yes.
Okay. Okay. Sorry.
No, it's fine. So all that we were doing before was on like on a Pandas series, but this is on the entire data set, or the entire data frame. And so you cannot subset it using the index labels. Like if we all remember, so from the data frame, the datetime, like these are index labels. So you cannot subset, you cannot use the square brackets to subset the data frame and by providing the index labels. If you provide the column names, rather, it will subset it. Yeah, so let me, hopefully I'm not jumped. So 3.4, let me see. 3.4, I think. Okay, yes. So, and if you wanted two columns, hopefully this works. Let me see what Nino 4. Okay. So we have something called Nino 4. Okay, this no, you need two brackets for this. So I think let me see. Okay. So if you want to subset the data frame using the square bracket method, then you provide the label names you provide are the unique column names and not the index labels. Okay, so there's something similar here. So maybe I just jump this, and I'll just jump this because it's similar to what we've already been talking about. Okay, let me run this. Yes. So previously, like I said, we're still working with Panda series, yes. So it was possible for us to use an index to print out a specific value. But when you're working on the data frame, you cannot use the same notation yet. So as you see, that's why you get an error. And so you cannot use the same notation when you do that. Oh, sorry. I was trying to get rid of the error. Yeah. Okay. So here we see how to, if you still want to use the index labels, this is how to use the index labels, but you have to use it in conjunction with a unique column name. And so this is the what is usually referred to as the chaining. I think, yeah, hopefully I'm not wrong. I think it's chaining. So you provide one instruction and then you chain it to another. So what this does is that what this code basically means that you have this data frame, and inside this data frame you want to subset this column, this 3, 4, and then within this. So what you find is that once you have just this, you now have a Pandas series, and so it's easy to apply the label to it. Pandas does not usually prefer this, but just for us to understand like where we are getting to, just to provide some basics, just help with understanding when we start using more like Pandas preferable functions, and yeah, some of these things are not clear. Yeah, then you already have the understanding. So this kind of gives us a similar output to when we're yes, gives us when it's not lock, by the same as lock, but also I think we had it somewhere up here when we're focusing on the series. Yes. So oh, where was I? Where are you? Okay. Okay, we are here. Yes, and similar to this, once you are using this to create this part of the code to create the Pandas series, you can then apply the labels or use the index. So I think this should also give us the same output. Yeah. And so once again, if anyone has a question, like I said, you can always just open your microphone and yeah, just chime in. Yeah. Okay.
Sorry, Daniel, real quick, I do have to go to another meeting.
No problem.
Thank you.
Yeah. You're welcome. Okay, so I continue and yeah, here we are. So as we've been working, like we've looked at 4 types of extracting specific data from either a Pandas series or a Pandas data frame. And so we looked at this lock and iLock. We looked at using the square bracket method and then using the index. And so once again, we want to see, but we applied those earlier. We were applying it on the Pandas series, and here we are applying it to Pandas data frame. So if you want to use this lock module, and this we are doing the dot notation where you just put a dot beside the data frame and then you call out the module, specific module. And so what's this, the way this works is that this works in kind of like an XY way. Maybe let me yes. Okay. So the way this this lock module works is that if we want to extract this specific data point, this 26, this temperature value, I should think it's temperature, yes, temperature value of 26.72 Celsius. So the X component of this data value is 1982, is 1st January 1982, and then the Y component is this 34, and so that's how you provide the arguments into the lock module. Where are you? Yes, here. So you provide the X, and then yeah, I'm using X, Y, hoping that it will make it easier. Yeah, so the row first and then the column. The row label and then a column label. Yes. Okay, so we get the same answer. And also similar to just obtain a specific value, you could also obtain an entire rows information. So you provide a label, as you can see clearly here. You provide a label when using the lock module. So So this, if this is not clear here, okay, so 1982, so 1st April 1982. So if you go back to the data set, 1st April 1982. So what we've done over here is to extract all the data points for different variables which pertain to this unique label, index label, yeah, which is 1st April 1982. Hopefully I'm not wrong. Yes. Yeah, so we are here, I think. Okay, we'll move past this. Yes, so this is the last thing this is the last cell we run. And also similar to how we worked on the Pandas series, you can also obtain a range of output using lock. So again, back to Emmanuel. So instead of doing head, another option is to use this lock and go ahead to provide a range of labels for which you want to extract the data for. So this is another option. Yeah. And now we move on to using the iLock module, which is usually based on the indices or the index, yeah. And so I run this cell. And so once again, this is I think position 4. So this is 0, 1, 2, 0, 1, 2, 3. So 0, 1, 2, 3. And so you have this row of information, yeah. And it renders this vertically, but yeah, it's related to this row. And once again, similar to what we had about, you can still use the index method to obtain like a subset of the data. So next up, we want to see how to combine both the rows and column names. Yes. So I run this cell. And so I should think that it's possible to do in other programming languages. And so what you have here, the difference is that here, when we use the index notation, because we didn't provide which specific columns we wanted to extract, it provided information for all the available columns. But here you notice that we indicated the column names. And so it only limits it to the column names that we provided. And then you have their unique labels, which we provided here. And as I mentioned before, you always provide your X argument and then your Y. And so this is referring to the Y argument, which is a column. And so you realize that there's a comma here. And so this separates this first argument from this other argument. So as it says here, you use this to slice the rows and use this to list the columns that you want to focus on. Okay, any more questions? Are there any questions? I should think. Okay. Okay, so just for continue. Yeah. Now there's a lot of talking. Okay, so now we want to explore the data further. Okay. I hope Emmanuel is still with us. So as I tried earlier in the notebook here, you already see this here. You already see this head and tail applied here. Okay, let me try and go here. Head and tail apply. Let me see head and tail. I think probably there was a question I wanted. Okay. Okay. Yes. So as we demonstrated about, this is the same. And maybe we try to see if, so this is iLock, right? 0.5. So this is this df head is the same as df iloc, and then you provide this argument. So it's the same. And if you wanted to see the tail, I think probably since the tail no indexing starts from, I think starts from negative, right? So 6, maybe this will be the -6. Let me see. Let me try and see if we can use this to, so this is -6 to the end. Okay. So -6 is too much. This is just 5. We need 5. We need 5. So so this is also another way you can index or you can see the last part of your data frame, the last 5 rows of your data frame. So this is similar to what you have here. Okay, so next up, want to generate some quick plots, but please, are we running our notebooks alongside? Like, if you are running your notebook, if you can raise up your hand, I just want to know if like we are following or running our notebook alongside. Yeah, if you can just give me a, what do you call it, a reaction or something. Yeah, hand raised or something. Okay, I see Abimbola is running alongside. Yeah, hopefully she's following everything. Okay, I'm not seeing any more reactions. Okay, great. Okay, great. Okay, nice. Okay, that's nice to, yeah, that's good to know. Yeah, yes. So mainly what we've looked at is how, like, different ways by which we can extract data from our data frame, how to view different aspects of the data frame. And now we want to, I think usually, this is usually when you are trying to get to know your data better, trying to get a feel of your data sometimes. Yeah, it's not too entertaining, or maybe just a few people enjoy this. So yeah, we'll get to another part where people might probably enjoy more. Yeah, so we are going to do some data exploration by visualizing the data that we have. So this should help us explore like what the data is about, the kind of the behavior of the variables within the data. And was it yesterday? Yes, it was yesterday. Yesterday, Greg was taking us through matplotlib. And what you find is that in Pandas, so if you see from here, we've not imported. So yesterday, Greg explained that if you want to do plotting, yeah, you need the matplotlib package. But as you can see from the libraries that we've imported, we've not imported matplotlib, but we are still going to be able to plot. This is because Pandas has its own inbuilt plot functions. And yes, so where are you? Yeah, yes. Okay, so we are going to look at what this Nino34, yes, what this Nino34 data looks like. And so here we are using the dot notation. And so within this data frame, you want this column and you want to plot. So I run the cell. Okay, so it's a line plot, then yes. So this temperature here, and then you have your time. And we see the behavior of the Nino34 variable. Yeah. Yeah, and it's always helpful. I mean, this is one of the basic plots you can make, but it's always helpful, or it gives you like a first idea of what your variable, its behavior, how your variable behaves here. Yeah, and so you can use different visualization methods. We've used a line plot. You can also use you can also explore the variable behavior using histogram or pie chart, area plots, yeah, that kind of thing. So here, what we want to do is that so within this data frame, we want to, so we want to subset these columns, these two columns. And so you have the double brackets. So this is like your list of columns you want to subset. And so that's how come that's for the first square bracket. And then you put it within the other square bracket, which tells this data frame that you want to subset these two columns. And then we plot this column. So as you can already tell from here, if you don't, this is if you just call the plot function, it gives you the default is to produce a line plot. But if you want another kind of plot, you just, so if we want a histogram here, so we add this dot hist. And so it gives us a histogram. Yes, and I find that, so yeah, this is cool enough, but also if you look at this Nino 1, 2, from this histogram, we probably cannot tell if part of the data extends all the way here. I mean, if you go back into the data frame, you should be able, you will see some values which show you that this Nino 1, 2 has values here, but yeah, if you use a histogram, so probably a histogram is not the best visualization method to use here. Yeah, probably not. So we'll try another one. So we'll try to produce a box plot instead. So once again, we are subsetting our data, applying the plot function and calling dot box to produce the, yeah, so we have a box plot here. So like I said, like already, as you can see, if you look at this box plot, you can see that for this Nino 12, you have temperatures extending close to 30 degrees, maybe probably around 29 point something. So you can see that here. So Nino 1, 2 is this, and here Nino 1, 2 is blue, but you can't see it's here. You can't see whether it extends here or it just ends here. So if you use a box plot, it allows you to better see the variation of the variables data points, the observations for the variable, how they vary, yes. And if you, so within your notebook, if you click this link, hopefully it opens quickly. Yes, you can see. So this is the documentation for the Pandas package. And there are different types of plots we can produce. So there's a line bar, there's different, like, so these are the various plots then that we're calling. So maybe let's try this area and see how that will look like. Okay, let's see. Okay, so let's create a new cell here. So just copy this and paste it here. But now instead of box, you want to see area. Oh, okay, cool. Yeah. Yeah, so this also allows you to better explore the behavior of your variable. And so here, like you can see clearly the behavior of this Nino 12 variable and Nino 3, 4. Yes, so you can also try, like if you move back, if you click on the link here and it opens this web page, then you can also try other types of plots. But you should definitely be aware that it's not every plot that is going to produce an output because of the kind of data that you are working with. Yeah, because probably if you use scatter, you need X, Y variables. So if you don't have that, then it will not generate like a plot for you. Yes. So I think also probably yesterday we looked a little at how to customize our plot, how to add different labels, and yeah, how to add different labels and titles and yeah, increasing our figure size, changing the color of the plot and stuff like that. Yeah. So that's what we do here. So you find that this is the same. This is the same. Basically, this is the same we had here at the beginning. I think this. And so maybe if I get rid of this. So all we started doing is just providing arguments into the plot function to see. So yeah, so this we change the color of the line plot. The default color is blue, and now we change it to black. Yeah, let me try something like red. Hopefully it works. Okay, yeah, it works. Yeah, and then you can also see if you wanted to. So all the codes are just below. So if you wanted to see, if you wanted to make, probably it's not wise to, because of the variation, it's not wise to make the lines thick, but we just want to see what it looks like. And so we'll probably make this maybe like 5. Okay, so not cool, but mainly you can, and you can also make it like really thin. Yeah, okay. Yeah, so we're adding different different customizations to our plot. So I'm just taking all from here, but I'm just trying to build it line by line just for us to see. So we can provide a label. So if you can have your X label. And then yeah, what is, so you always provide a string as the name. So what is the label? Okay, time or year, maybe time. Okay, maybe year. Okay, as is there, or maybe time. Oh no. Okay, so you see the time, and then maybe we can also provide a Y label. Because all the code is just in the cell below. And so we are being told that this is the ENSO 34 index, and it's in degree Celsius. So this is ENSO 34 index, and probably I usually like this. Okay. Okay, so yeah, it's the same as we are doing here. Then you can also change the figure size. Yeah. So we've been at this for some time now. Yeah, maybe I'll just continue and then we finish up and then take some questions if there are any. So yeah, this is how to use the plot function within Pandas rather than to import. You could also import matplotlib and then do similar plots. That's also another option. And I want to go to explore a little bit of descriptive statistics. Just have an overall general idea of yeah, the data that we have. So in doing this, you can use this function describe, and so you apply this function to the data frame, EF, and yeah, it summarizes the entire data frame. So for all the different variables, you have a total of 472 observations, and this is the mean across the entire time frame. This is the standard deviation, the minimum temperature, the 25th percentile, the 50th. I think this is the median. Yes, and then 75th percentile, and then the maximum temperature. And you have that for the different variables. So any questions? As always, if you have a question, you can just open your mic and yeah, just chime in. Yeah. Okay, next up. So when we use describe, you realize that it applied, it gave us the the descriptive statistics, it gives us for the different variables, but then you can also try to get a statistic individually. And so if we apply this df.mean, you apply this mean function to the data frame, then you are going to get the means for the different variables. So it's just this mean row, this row that we are, this row, this row, oh, sorry, this row, this is what we see here. And if you want for just a specific column, you just want the mean for a specific column, then you can have that too, rather than all the columns. Okay, slices. So what next? We are going to be looking at how to subset data using the datetime column, which is our index label. And so, okay, so let me run this and then I try to explain. Okay, so what have we here? So we know that, okay, where's our data frame? Like we already know that, okay, maybe let me just use this as an example. We already know that this is our index label. This first column is our index label. And so within that index label, which is a datetime object, because a datetime object, that's how come you can have this month. So because the datetime object, now we want to, so in Python, this is how to write equal to, sorry. This is how to write equal to. You don't use, because we use a single equal to assign information to objects. We use it for assigning things to objects. So the way to write equal to is to use double equal to, and that means that equal to, yes. So it's saying that what does the code here do, or what does it mean? I mean, you can see what it does here because of the output, but mainly what it's doing is that you are saying that within the index labels, okay, go into the index labels, look at the month which like only pick out the months which are equal to the first month, which is January. So only pick out the January months in all the different years. And once you pick out this January months, then use that list to subset the data frame. So let me try this. Let me see what we get with this. Let me see what we get with this. Okay, yes, okay. So you see a lot of Boolean operators here. So mainly the way the code obtains the value is that it just moves through the data and just tries to see which cells within the data frame meet this condition that's been provided. So you see that it's only the first. So here you see you see one true here because it's just one. Within the year you have 12 months, and it's just, you can only have just one January, and so this is true, and so it only picks up this first month and puts it here, and then it does the same thing for the following year, only picks up the January, and so that's how come you have yeah, you have this. So mainly this is what this argument does. Yeah, so it's another way to sometimes help yourself understand your, I mean, if you see code somewhere you can understand it. Usually codes are already written together as a whole, but you can always pick them apart just to observe what the different parts of the code does. Yes. And so we have this output. So we only have the data for January months, yes, in the different years. And also one thing that we or one thing that you can take from this, that this is also another way, using this index, applying this index.month to the data frame, you can also create a new column which has information on only the months. So I run this cell, and then, okay, it shows nothing because we've not printed. So I just print df. And when you print df, you realize that you now have a new column, which is the month column. And so it identifies every month. Yeah. And so you've been able to create a new column. So based on this month column, you can also find the monthly mean values for the different variables. Yes. So, okay, this is, maybe we'll just break the code down. Maybe let's try to just break it down to just see. So this is the entire line of code, but we just want to break it down to see, just to help us better understand. I hope this should work. Let me see. Okay, this will not give you any output. It will just tell you as been grouped. Okay. So mean. Okay. So what do we have? So I just reproduce this part of the code just to help us see the data that we are about to plot, the data that we've extracted that we are about to plot. Yes. So what you have is that you have 12 months. So you group the data, by month, you group it into monthly data. And so all the January values, in a different, all January values in different years, you put them together and you find their mean. So that's what this means. So that's what you did here. So you take the month of January in, say, maybe 1992, 1993, 1994, and then you find the mean of all these values. You find the mean of all these values, and that's what will be shown within the table. And so we want now plot the main values that we have. So we are plotting this table, and yeah, intuitively, Pandas nicely renders this plot, and you have, it's already provided us with a legend that nicely identifies the different variables. Yeah, and they've been color coded nicely, and then we can see them. Yeah. And so that's what we got out from the plot. Additionally, sometimes when you are working with your data, you just want like a subset of the data that meets a specific condition. So say maybe you have temperature values from, say, maybe 0 to 50, and you just want values that are, say, maybe below a certain threshold. So you can also use what you call conditional indexing. So you are using index, but then you're providing a condition. So the data points that meet this condition will be subsetted within the main data frame. Yeah. So we try one now. So we have this Nino 34 anomaly or anom, and we want to see. So it's an index. It's an index, not in terms of indexing, but like it's an Enzo index. Yes. Or I think they usually call it they call them ONI. So this anomalies are usually called ONI. Let me see. I think it should be somewhere on the page. Okay, yes. So Oceanic Nino index. Yes, I think that's what it is. Yes. So you want all indices that are greater than 2. So that is so you're indexing and you provided a condition. So like I said, the data points that meet this condition will be subsetted from the main data frame. So let's run this cell to see the output. So to see that what we have is actually working. So if you look at this, for a norm, you realize that you don't have any output that is greater than 2. They are all below 2 because that is a condition that you set. So, oh, sorry. We are using this 3 for anomaly, sorry. So the condition you set is that you want values of this 3 for anomaly variable, values of this variable that are greater than 2. And so, yeah, sorry, my mistake. So all the values that you have here are greater than 2. So you only success the data point that meets the condition. And next up, you see here, the values are just not in order, in any specific order. And so you can apply this function sort values to sort the values, I think, I guess. Okay, no, so this does not necessarily apply to this data frame, sorry. So in our original data frame, which is called DF, you can also sort values in a specific values based on a specific column. So if you indicate the column on which the sorting should be based, then the sorting is going to be done that way. So as we've seen from below, I think every time we call this our DF data, it's always starting from 1982. It's always starting from 1st January 1982. So let's see what this sorting, what the output for this is. So if you observe the 3 for anomaly values, I think this is decreasing, or yes, okay, so this is decreasing. So the default method for the sorting is ascending order. Yeah, it's decreasing, right? Is it decreasing? Yes, it's decreasing. Yes. So it's in the default is ascending order. And if you look here, you realize that in our original data frame, you see that the first index value or index label, sorry, is 1982, but now it's 1988 because it's this 1988 row that has the lowest 3 for anomaly value. Yes. So that's how come we have it this way. Next up, if you wanted to see, like I said, here is increasing. So if you wanted to view the values in a descending order, decreasing instead of increasing, you can set this argument ascending equals false. And then now you realize that the arrangement has changed, and now you have the highest value as the first row. Yes. Yeah, I guess it's easy to understand. Yep. Next up, we want to do resampling. Yeah, we want to look at resampling. So when you're working with long time series, you see sometimes you want to observe if there are trends. So this is the time series plot that we made for one of the variables in the data frame, and you realize that there's a lot of a bit of noise because you have a lot of variations, and you are not able to clearly see any particular trend. So if you want to see trends, then you could use this resampling option, or this resampling method. So you can do resampling. Resampling better allows you to view trends within long time series. Yes, so okay, we'll plot the 3 for variable again, which is the plot that I just went back to. I just realized that it's here. And now we are going to resample it on a yearly basis. So we are going to find the mean over all the years. So for every year, we find just one mean value for that particular year. And then we plot this mean value. So this we are focusing on this column and want to resample it by year, and then mean, yearly means, yes. And then we plot this mean values, yeah. And so now this is a little bit of an improvement. You can see, you can observe better, like you have less like variations and more like you can see like a trend where the how the variable is changing, yeah. So this, we've just looked at resampling, and I think before we looked at how to use conditional indexing. And now we want to see how to apply different operations on a data frame. So you have a certain kind of data set, and you want to change certain parts of the data. You want to transform them into a different form, just to help you better work with the data, or yeah, but towards maybe helping you communicate better some kind of information. Yes, so you can apply different operations on the data. So as you can see here, so this temperature values, okay, so I already saw the data. And so these temperature values are in Celsius. And now we want to apply a function. We want to define a function first, apply a function to a certain selected column within the data frame to transform the temperature values from Celsius to Kelvin. So that's the function that we have here. So def is how we define functions in Python. And we are calling our function convert degrees Celsius to Kelvin. And for this function, the arguments we are going to provide it is this temperature degrees Celsius, which is intuitive and helps you better understand the function, what it's going to do. So the value you're going to provide is in degrees Celsius, and you want the function to return this new value of temperature, but in Kelvin. And so here we are just converting the degrees Celsius to Kelvin, and to do that, you just add 273.15 to the Celsius value. So I'll load this function. And so now we define our function, convert degrees Celsius to Kelvin. So if we want to, so this is just to test the function. So we've defined it here, we've called a function now, degrees Celsius to Kelvin. So if you have a temperature of 0 degrees Celsius, what is this equivalent value in Kelvin? So it should be 273. Oh, this is taking long. I see. I don't know why. I shouldn't take this long. Okay, it's still running. So as you can see, the asterisk sign here meaning it's still running, as we usually know. So we just give it some time. Ooh, it's taking a while. Yeah. No. Okay. It's still running. But has anybody following? Has anybody been able to run that particular cell? I don't know why mine is taking this long. Maybe I'm using too much memory. Has anybody been able to run that particular cell? If yes, you can just open your microphone and let me know. Has anybody been able to run that cell?
As I have run it at the beginning of the class. Like I just run the whole cell at once.
You mean the whole notebook?
Yes.
Okay. Okay.
So I have 273.15.
Okay, that's great. Side comment. I think I saw.
So I've also run mine.
Okay.
Yeah.
Then sorry, I have a question about the resampling.
273.
Hello, Musa.
Yeah, I also ran mine.
Okay. And you have an output, right?
Yeah, 273.15.
Okay, nice. And Abimbola, yes, I'm listening to you.
Yeah, about about the resampling.
Yeah.
I don't know, is the one y, is it a constant, or what if I want to do 1 month or daily or something like that?
Yeah. So if you want to do 1 month, this is what you do. So here, if you want to do 1 month, then you group it by so maybe let me go back. So there is something is similar to group by. So if you observe, we have the data that we have is daily data, and so for
Yes.
every, sorry, it's monthly data. It is not daily data because this is the first month of January, first month of
Okay, fine, yes.
yes, it's monthly data. So it's by month, and where are you? Where are you? Where are you? Where are we? Oh, where is month?
That's the resampling.
Yeah, I'm trying to show you. I think we group by month. Yeah, at some point, yes. So if you want to show monthly, right? That was your question. So you mean like this? You mean this plot? So this you see every month.
No, there was a plot that was actually so busy and clumsy somehow. And we actually regroup and we have something. Yeah, this one was
This plot,
somehow
yes.
clumsy.
Yes.
Yes, and we try to regroup to have something more explanatory. So
Yeah.
I'm saying, okay, what if initially we have a data that is daily instead of we have monthly now, and we made a plot. Let's say we made a plot of by yearly with what we have, but I want a specific point, and I group by month, but I want to group by day. How do I input that?
Okay.
Like I'm asking
I
out,
get your
like
question.
this one Y that you use, is it a constant, or how do I input the command in Python to make it to let the Python understand what I want to do?
Yes. Okay. Yeah, I get your question now. So for to do it on a yearly basis, this Y thing is a constant. So I'm not trying to check how you would probably do it on a monthly basis. Yeah. So something. Yeah, just I mean, so like I said, always you can always just look things up. Okay. Okay, so as I try to find the argument, just a quick comment. I see somebody on a call. Where are you? Okay. I just want to give somebody information so I don't miss them. I think. Oh, where are you? Is it Marilyn? I'm looking for. Is it Marilyn? Oh, I lost her. Okay. I was looking out for one Marilyn. Yes, because she sent us an email that she was having trouble with her local Conda installation, and I wasn't sure. We didn't get a response back from the email response we sent her. Okay.
I installed.
You installed it. Okay. Okay,
Yeah.
great. Okay.
Yeah.
Yeah, I was looking for you. Okay. I tried to look for you on Slack, but yeah, it was difficult to find you. I didn't know your Slack name. Yeah. I mean, but I'm still looking for your argument the argument for the monthly. How to sample. Okay, this is where are we? How to use sample on monthly? Yeah, okay. Okay, maybe I'll just produce this. Let's see. Is this different from this? It looks similar. Okay, so I think you can use so yearly is this 1Y, and then for monthly you can use M. I think for monthly you can use M. I'm not sure about daily, but for monthly you can use M. Maybe I can check if there's a daily option also. Yeah. But for instance, in this data set that we are, okay, our data set is monthly, but if you had daily data and say it was a long time series, then making a plot on a daily basis will show a lot of variations and probably will not allow you to better observe trends. But yes, if you want to do this on a monthly basis, I think you can use this M argument. Yeah.
Okay, thank you.
You're welcome. Well, okay, we're defining functions. Ooh, my cell is still running. Oh, this is. Maybe I'll try to stop it. Well, I don't know why. Maybe I've used too much memory. I don't know why. Yeah. Maybe I'll just jump ahead. Whoa. But how about if let me see if I have solutions here. Okay. Yeah, so this is a notebook that has already been run. I don't know why this one is misbehaving or is lagging, but yeah, this is one that I've already run, so we can probably continue from here. So similar to what others had, so the output is 273.15, so that's the equivalent temperature in Kelvin. Sorry. And yes, additionally, what we can also do is we can subset the a data frame. And so if we subset a specific column within the data frame, then we have a Pandas series, and we can then apply the function onto apply the function on a series to convert all the values within that series, all the temperature values from Celsius to Kelvin. So this series we already had. Oh, I probably shouldn't have run this cell. So pardon me, this we are getting an error because I've not run the cells from above. So I'll just, so I should not run cells. I should just go through the code. Let me see if we have, okay, it's still running, and so I cannot use this. So back here, yeah. So if we subset so another function or module you can use is type to see the type of your data, the data type that you have, whether it's a datetime, whether it's a NumPy array, it's a Pandas data frame, Pandas series. And so here, what we've done is to subset this Nino 1-2 column, and we just want the first 10 observations. And we want to see what type of the data type of this output. So I'm not going to run it because then we'll get error. So if you run this cell, if you run it in your notebook, you get this output, which tells you that the output is a Panda series. And if you add this dot values function to the code above, then you're going to have a NumPy array. So the main difference is that, okay, so like visually this will render as the output. If you try to get this output, you are going to have it like rendered in a vertical form. This will render horizontally, like visually. So that's like visually that's a difference. But this gives you, unfortunately I cannot run my cells, but this gives you the cell, this takes, so this will give you the Panda series, and then these values, as the name implies, will extract out the values within this range. And once the values, only the values are extracted, you now have a NumPy array and no more a series. Okay, so this is the output. So here, because you apply the type, it just tells you the data type. And here you see the output, like the output in terms of the values. And so, yes, as I mentioned before, once you obtain a Panda series, you can then apply a function, or you can then transform that series into a form that you want. So now that we subsetted the 3, 4 column, we want to convert the temperature values in degrees into Kelvin. Okay, we are almost at the end, and it's almost time. I don't know if Greg is around. Greg is not in yet. Yes, but we are almost at the end. Yeah, I'm sure we'll all get like a small break before the next tutorial starts. So if you apply this function, this convert degrees to Kelvin to, if you apply the function to the series, then you are going to get all the values within the series converted to Kelvin before they were in Celsius. So that's what you get with that. And here you see renders this as a series, but then if you try to extract the values, then it will print out all the values within that, all the values for that variable. And this will be, as you can see, it's a NumPy array. And so we can, based on this series, you can now have a new column, which we call still Nino T4, but then instead of degree Celsius, it's in degree Kelvin. So I'm not going to run a cell again. I nearly did that, but I'm not going to run it. And so this is the, when you run just this, you don't get any output because it creates the column and adds it to the data frame. But once you run this, you should see the new column here, as shown here. New columns always added at the end. And once, if you want to see it in a series form, this new column that you created, you can just subset it, use the dot notation, and then you get that. So what we try to do here is to write this new data frame, like this data frame that we have here. No, this new series into a CSV. So this is another function in Pandas. So maybe sometimes you might even be working with netcdf files, or satellite data. You want to extract some values and put it into tabular data. So you can use Pandas. Once you are able to create a data frame out of whatever data you have, be it netcd or whatever, if you're able to create a data frame from that, then you can use the CSV function to write that data frame into a comma separated file, comma separated value file, CSVs. So this is what we do. This is what we do here. And then if you go, so I didn't run it because then we might get an error. And so if you go, if you open your folders within your own local hub, then you should be able to see this this new file created. which is a CSV file, which is like the name that we gave it here, which is, yeah. And because this is our working directory where we are working in, so it will save the file right within the working directory. If you want to see the working directory where you are currently working, you will use this command pwd, which means print working directory. And so it will print the working directory, which tells you that you are here, blah, blah, blah. And then you are in this folder Pandas, which is the same here. And so we are here, and that's where the data will be saved. Yes. And yeah, so once again, if you wanted to read the data, the new data frame that we've created, I mean, by converting this series from Celsius to Kelvin, if you want to read it back into our notebook, then we apply this function, which you've seen above. And so, wow, we are at the end now. Yeah, it's been quite a while, but we are at the end. So what we've mainly looked at is Pandas in general. Like, we try to look at a few of we've looked at the kind of data that Pandas is able to handle, which is tabular data, and different ways by which we can subset our data, extract specific values, and yeah, slice the data. We've done a little bit of exploratory analysis. We've done a bit of data transformation, a bit of what else did we do? A bit of statistics, yeah. So we are at the end now. Anybody has any question? So please, if you have any question, you can, as always, open your mic and yeah, chime in with your question. Any questions? Anybody with a question? Okay, I'm going to stop the recording, and yeah, I'll be here for a while.